From today's section, let's talk about advanced testing techniques using Golang. Okay, so basically, Golang you can do the mocking and the dependency injection. In Go, actually, you can use interfaces to define dependencies and then create a mock implementation for testing. We will see that with the hands-on, and also you can use the subtests and parallel testing in Golang. Go actually you can run the subtests to organize tests and run in parallel. Okay, we'll see that in a hands-on. Okay, in advanced testing. So what we will do is we'll try to use the advanced testing techniques basically for mocking. So what we will do is we'll define one interface. I am thinking I will take some geometry. Okay, geometry package. Basically, what we will do is we can try to use the I can say geometry dot go. Okay, so I can say here is package geometry. What I will do, I will try to use the basically I can use the shape interface. Okay, which will have the two functions like area float 64. Basically, this is the method, and also we can use perimeter also float 64. Okay, I think that's it. This much only we'll use in the in the geometry.go. So what we will do is we can create the test file, and we can also try to add the dependencies in the geometry package. Okay, so what I will do is I will try to create geometry underscore test dot go. Okay, in this file package geometry. So what I will do is I will try to create a type mock shape. We'll trying to do the mocking here. Okay, so I can create some variables float 64, perimeter also float 64. I will use some kind of boolean variables like area called boolean. So this bool things I can use it. Now what I will do is I will try to implement area and the interface whatever this has the two methods, right? Area and perimeter. I will try to implement those things here. Mock mock shape area. Okay, and it will return float 64, right? Right. And what I will do is m dot area called equal to true because we are calling that, and I will try to return m dot area. Okay, similarly we will try to call the perimeter also here. Okay, uh, dot perimeter called equal to true, return perimeter. Simple. Okay, So once this is done, this is the mock implementation is done for this. Now what we will do is we will try to call function uh, test shape info t star testing dot t. Okay. Okay. So in this one vector, what we will do is mark rectangle equal to. I will try to mark shape of area. Probably I can take 20.0 perimeter. Assume that some 18.0 because these are the floats. Similarly, mark circle also we can track the same thing. Mark shape. Okay. Area. We can take some 27.9. Perimeter will be assume that 17 18.5. Okay. So now what we will do is we will try to what we will do is okay. Hmm. So what we will try to do is we will try to implement some method to print shape info. Okay. Just print shape info. I think we can try to implement here in a method called func print shape info of shape name string and yes is nothing but a shape. Okay. Here we are doing nothing. Area is equal to s dot area. Okay. Perimeter is equal to s dot perimeter. Right. We'll try to just print the fmt dot println percentage of s. I think that's okay. We will try to use println only. This is not required. We can use the shape name, right? Shape name, and then what we can do is we can try to print the uh, printf of Basically, I'm just trying to bring to two decimal points. Okay. Okay, and then I can print perimeter also similar fashion. This is perimeter. Okay. Okay. I think that's okay. Now look, go back to the our test case. So what we are planning to do here is we are planning to implement the same thing here actually. Okay. Just print the shape info. I'm taking this one. Now what I will try to do is I will try to print shape info rectangle mock rect. Okay. Comma T. Okay. Similarly, what we can do is we can try to call circle mock circle. Okay, and T. Okay. So now what we can do is we can try to use the assertions like if mock rect dot not area called or not mock rect dot call, then you can just error it. Expected to call area and perimeter methods but not called. Similarly we can try for circle mock circle. Okay, not called for rectangle, not called for. Okay, so that is the way actually you can try to mock the test cases basically. Okay, let me run this. Okay, shape only, right? I think this is not required. Okay, okay. So what we can do is we can run this test and see what happens. Perfect, it is working. That means that mocks and all like it's working as expected basically. This is how actually we can mock the test cases and we can try to run the things. Okay. This is how actually this one, and we will try to run the other things like whatever we discussed, like parallel things, right? Parallel execution or subsets of the test cases execution. Okay. So let's do that. If you see, right, we are printing all the test case information also here, right? Whatever we are expecting from the test case. Perfect. Cool. So let's move on to the the interface related changes. Let us do that. Okay, rectangle. So from the shapes, basically what we can do is we can try to implement the rectangle and and circle functions in the here. Basically, let us implement the type rectangle struct. Rectangle will have two things, right? One is width of type float, and also we have height. Okay, these two things we have. Let us implement the rectangular things also. Func of r rectangle of area, and it will return float 30, float 64, right? This is nothing but no, it's simply return r dot height into r dot width. That's it, right? Similarly, we can write we can implement the perimeter, right? Perimeter basically 2 into width plus 2 into height, right? To width plus 2 into width, basically like the things. Similarly, what we can do is we will try to implement type circle obstruct. Basically, for the circle, you need only radius, right? It is a 4 plot 64. Okay, now what we can do is we'll try to implement these two functions for the circle also. So what we can do is the circle, right? Circle area c dot. Just like area will be like a what is the area? Formula is that 2 pi r square basically, right? So what we can do is c dot radius into c dot radius. Okay, and perimeter is like a 2 pi r. That is nothing but 2 pi r, right? 2 into math dot pi into c dot radius. I think that is the implementation of these two things. Let's move on to the our test cases, right? So from our test cases, what we can do now is to make it sub things. So what I will do is I will try to write one function to verify our geometry. Okay, uh, geometry, and it will take testing. Okay, So now what we can do is the t dot run for rectangle. This is basically subtest, okay? Rectangle. Take the take the function, which again takes testing.t, right? And then I need to implement the things within the test. What is this? So it is rectangular is it? Okay. So this is actually subsets of the things. Okay. What we can do now here is uh, r is equal to rectangle of width probably 4 comma height assume that 5. Okay. What we can do is basically mm, let me write one simple command method which actually take the testing followed by rectangle comma the whatever the shape. Okay, let me write what is the function of func check shape t testing dot t shape name string and yes shape. What we will do is we will try to make the parallel. We are enabling the parallel here. T dot run area of function func T dot testing dot t. Oh, okay. So here what we can do is we will try to calculate area equal to s dot area. Okay. Now what we can do is expected area equal to. We will try to calculate, expected area. I think we know, right? Expected area could be 20, right? 4 5 is 20. Basically, we need to, get from the other function. Calculate expected area for shape name. Come on, yes. Okay. Let us do here actually what we can do is we can do the switch actually switch off shape name. Basically, what we can do is case is if it is rectangle what we are doing is 4 5s, right? uh, just there is like height into width that is actually written what 20 4 5s are 20, right? Correct. Okay. In case of circle, what I'm thinking is assume that I will give the circle rectangle this much. Circle probably we will see. Okay. For now, let us fix the things for this one. So coming back to the expected area we got right as per the calculation. Now what we can do is if area is not equal to expected area, then t dot error f of, we can see that expected shape area to be percentage of dot 2f but got percentage of dot 2f. So here we can take shape name expected area, right? And the area. So this is how actually we can try to, okay. So if you see that we know the expected output and you can keep improving these test cases basically. Okay. I think something is failing here. Let us see what is that. But missing written at line number 2064. 64. Okay. Okay, let us run this test case again. Yeah, that's it. It is working as expected. So this is how actually you can run the subtests and parallel tests. Similarly, you can write, currently we wrote for rectangle. You can write similarly for circle also. Okay. Let me write fastly that circle. You can write here CAR CLE. Probably I can use the radius of, probably I can use 3 circle C is the shape. So we have not handled it actually here, right? We didn't handle per circle here. 6 circle here in the case inside this basically. Return actually two. There is a, we have taken the radius as 3, right? It will take like 28.27. So we are covering like two test cases, the test cases also in the parallel. Okay, let me run this test case and try once again. Okay, expected area. Okay, 28.7, but expected area to be 28.7, but got 28%. This is correct only, but anyway, it's okay. We are taking more uh, decimal basically actually. That's because of that it is coming, but value is same only. Okay, nothing difference there. Okay, this is how actually we can improve our test cases thing basically. Okay, okay. Mm, mm, mm. Okay, okay. Okay, that what we covered here is that we covered the the test cases like subtest cases and okay, what is the happening here? But circle array is this one, but got this one. Both are same only, but problem is actually let me calculate here only, not 2 pi r, right? Oh, area of the circle. Basically, let me pass. Let me try to pass this test case with proper way. What we can do is here math.py into 3 into 3. This is the right one. Okay. Now this test case should pass 100%. Right? Perfect. So this is how actually we can debug and then we can try to. Okay. Now if you see it, all the test cases and reports and all proper. So as part of this session, yes, I want to cover the mocking the test cases. Okay. We are done with that mocking. And also I want to run the test cases in a parallel and also some sub-test cases basically. Okay. Okay. I think that's all about